Hello everyone. Today we will discuss about a specific heat capacity. To describe this, first of all, we take a bowl of water. We try to heat it with the help of burner. In starting, the molecule of water start moving, and after some time the water become turbulent, and means the speed of the molecules of water increases. So now take a timer and try to heat this water till 20 degrees Celsius and note the time. Let's take t seconds. Okay, now we try to increase the temperature till 40 degrees Celsius in the second case. Now we note the time. We see that the time taken is twice the time which is taken to raise the temperature 20 degrees Celsius. So in this case now time is 2t seconds. In the third case, now we take the double amount of water instead of double amount of water which we taken previously, and now we raise the temperature. We see that to raise the temperature by 20 degrees Celsius, the time is 2t. The time taken is 2t second. So now when we take the mass of water in double amount, the time taken to reach the temperature 20 degrees Celsius is double the time which is initially it is taking to raise 20 degrees Celsius. Means it is same, the time taken is same when we raise the temperature of water from 20 to 40 degrees Celsius and when we take double amount of water. In both the cases the time taken is same. So we will see here on what factors the heat provided to raise the temperature of a substance depends. We have seen the first case. It depends on the one case left. Now we change this water by oil and now we raise the temperature. We see that to raise the temperature 20 degrees Celsius, the time is very less than this t second. So this was the another case. So now we will see how many on what factors it depends to raise the temperature, how much heat is required, on what factors it depends. These are the factors with the help of this example we have seen. So first factor is temperature. To increase the temperature from 20 to 40 degrees Celsius, it takes double amount of time. So means when we provide more heat, the temperature to raise the temperature higher, we have to provide more heat. Another factor is mass of the substance, because when we taking when we taking double amount of water, then the time is taken also double. So second factor is mass. And the third is nature of the substance, because when we are taking water, the time taken to raise the temperature 20 degrees Celsius is more, and when we are taking oil, the time is taken very less. So these are the three factors: temperature, mass and nature of the substance, on which the amount of heat we providing and the temperature is raised of the substance. In these three factors are it is dependent on all these three factors. So now we will form a formula. We have formed a formula where heat provided is dependent on mass temperature, and the third factor is nature of the substance. We call it it is nature of the substance dependent on nature of the substance, or we say it specific heat. When it is called specific heat, so our this is the formula of heat. We provide heat to the substance. On this factor it depends. On this factor it depends. So now what is specific heat? Specific heat is when we take mass 1 kilogram of the substance and we raise the temperature 1 degree Celsius, and how much heat is required for that purpose for a particular substance, that is called specific heat capacity. So definition will be the amount of heat required to raise the temperature of a substance by 1 degree Celsius. So delta Q, when we are taking mass 1 kilogram, temperature raised is 1 degree Celsius into S. So this nature of the substance or specific heat equal to delta, so Q. So this will be our specific heat. The heat will be required this much when we take 1 kilogram of the mass and 1 degree rise in temperature. That heat is called specific heat. Now this is our heat. Now we will see the formula of it. What will be specific heat? This will be group 2 1 by m delta Q by delta T. So this is the formula of specific heat. Okay, and what is the unit of it? As is our specific heat. And what is unit of it? Joule per kilogram per degree Celsius. So this is the formula of specific heat. When we take, instead of taking 1 kilogram of mass, when we take m kilogram mass, that will be called heat capacity. So heat capacity m into s. When we try to, so what will be the definition of heat capacity? The amount of heat required to raise the temperature of m kilogram substance by 1 degree Celsius. So So this will be our definition of heat capacity. Specific heat capacity is the amount of heat we require to raise the temperature of 1 kilogram substance by 1 degree Celsius. But when we are taking m kilogram substance, so we multiply specific heat by m, then it will be called heat capacity. And heat capacity is when we try to raise the temperature of any substance, any m kilogram substance by 1 degree Celsius, that is called heat capacity. Now we will see the formula of heat capacity. The formula of specific heat capacity is delta Q 1 by m delta T. Now we multiply it with m, so it will be equal to delta Q by delta T. This is the formula of heat capacity, and its unit is joule per degree Celsius. So this is our formula of heat capacity. Now we will see molar specific heat. Molar specific heat. When we take 1 mole of the substance, instead of 1 kilogram, when we take 1 mole of the substance, then it is called molar specific heat. So, and the formula of it, instead of this mass, when we take mu, means mole, then S will be called molar specific heat, and the unit of it, molar specific heat, will be joule per mole per degree Celsius. So this is the unit of molar specific heat. Okay, and 1 mole contains the 1 mole. 1 mole is equal to the atomic weight of the substance. Molecular weight, sorry, 1 mole is equal to molecular weight in gram of the substance. Like we are taking oxygen molecule, so its molecular weight will be 32. When we take it 32 gram in gram, when we take 32 gram molecule of oxygen, then it will be equal to 1 mole, and it contains the Avogadro number of molecules, means 6.022 into 10 raised to power 23. It is according to the Avogadro hypothesis. According to him, if we take equal amount of gas, any gas, equal amount of any gas, then the number of molecules present in this gas will be equal, and at normal pressure and temperature. Here the Avogadro taken 22.4 liter of gas. If we get 22 liter of gas will be equal to 32, we are taking oxygen, the 22.4 liter of gas of oxygen. We can take any gas, here we are taking oxygen, that will be equal to their atomic weight in gram. So will be equal to 32 gram. So and it will contain Avogadro number of molecules, that is 6.022 into 10 raised to power 23. Means if we take 22.4 liter of gas, any gas, and that will be equal to the molecule of their atomic weight. So and that 22.4 liter of gas or 32 gram of that gas, both will contain Avogadro number of Avogadro numbers of molecule, and that is 6.022 into 10 raised to power 23. So this is our 1 mole. 1 mole is equal to molecular weight in grams of any substance. When we take molar specific heat of gases, then there are certain conditions which we apply. It is of two types. When we take molar specific heat of gases, molar specific heat at constant pressure, heat at constant pressure means volume may change. Here we are occupying only pressure, and we volume may change. This is denoted as Cp. So molar specific heat at constant pressure means we are taking or giving any amount of heat to the gas at constant pressure. We are keeping the pressure of the gas constant, and then we are applying or taking the heat, then molar specific heat, that will be called molar specific heat at constant pressure. And if we are keeping volume constant, then that will be called molar specific heat at constant volume. It is written as Cv. Here pressure can change. We are just keeping the volume of the gas constant, and then we are providing heat to it, and or try to derive the heat from it. That will be called molar specific heat at constant volume. Now the specific heat of water is very high. Specific heat of water specific heat of water, that is equal to 4186 joule per kilogram per Kelvin. So the specific heat of water is very high. That is why we use water in automobile radiator. Its application are automobile radiator, because water warms very slowly. And we also use in hot water pack. Because it remain hot for a longer period of time, it loses its heat very slowly. So these are the application of it. In Uh, now in summer, the water warms up very slowly instead of land. So the cool air flow from water to land. So we get the cool air from water in summer. We get the cool air from water towards land because water gets heated up very slowly because its specific heat is very high. So this is the topic specific heat capacity. Thank you.